Let's look at the graph of a function and what information we can determine from it. So first, we will look at how to identify the graph of a function. And we will use the vertical line test. Now, the vertical line test helps us to see that a graph is a function if and only if a vertical line intersects the graph in at most one point. And that's any vertical line that we draw anywhere on the graph. So let's look at some examples. So here I have 4 different graphs. Let's look at the first graph. I have y equals x squared plus 1. So I can draw a vertical line here, and it intersects at one point. We're going to pretend that all of my lines are vertical. I know that they're not all going to look perfectly vertical. I have drawing another vertical line here, and it intersects in one point. I have another vertical line here, and it intersects in one point. No matter where I draw a vertical line on this graph, it's only going to intersect this graph at one point. So this graph is a function. Let's look at graph B, y equals x plus 1 in parentheses cubed. I can draw a vertical line here, and it intersects at one point. I can draw a vertical line here, and it intersects at one point. I can draw a vertical line here, and it intersects at one point. No matter where I draw a vertical line on this graph, it also only intersects at one point. So this graph is also a function. Let's look at graph C. X equals y squared minus 3. So for this one, I can draw a vertical line here, and it doesn't intersect anywhere, but that's fine. I can draw a vertical line here, and it intersects at one point. We're still fine. But if I draw a vertical line here, it intersects at 2 points. And because I can draw at least one line where it intersects at more than one point, I can actually draw many, many more lines that do this. This graph is not a function. Let's look at graph D. X squared minus y squared equals 1. So I can draw a vertical line here, intersects no points, that's fine. I can draw a vertical line here, it intersects at one point, also fine. If I draw a vertical line here, it intersects at 2 points, and I can draw many more vertical lines that intersect at 2 points. This graph is also not a function. Okay, let's look at what other information we can determine from a graph. We're going to use this graph to answer questions about graphs. So first, let's find f of 0. So we want to know the output value, the y value, when our x value is 0. So that's asking about this point here. When x is 0, what is our y value? And that is 0. So f of 0 is 0. What's f of pi over 4? So pi over 4 is here. That corresponds to this point. Our y value is 2. So f of pi over 4 is 2. What is f of 3 pi over 4? What is f of 7 pi over 4? 7 pi over 4 is over here. It's asking about this point. Our y value is negative 2. So f of 7 pi over 4 is negative 2. Okay, what's the domain of this graph? So the domain, remember, looks at x values. And we want to go from left to right, from smallest x value to largest x value. So we want to find the leftmost point on the graph. And that's over here at 0, 0. And then we want to find the rightmost point on the graph. It's over here at 2 pi comma 0. And in between, there are no breaks, there's no holes, there's no asymptotes. We have a continuous line in between. So from left to right, our domain goes from 0 to 2 pi. And we do include our endpoints, our boundaries, our 0 and our 2 pi, because those are filled in circles. They're not open. so they're included. Let's identify our range. So we need to look at the y values. We need to find the lowest point and the highest point on this graph. So the lowest points are down here, these 2 points, 3 pi over 4 comma negative 2, 7 pi over 4 comma negative 2. Our highest points are up here at y value of positive 2. So in between these points, like there are no breaks, there are no holes, there's no missing y values. So our range goes from negative 2 to positive 2. We've got squared off brackets because we're including those boundaries, because we have close points, we have close circles, we're including those points. Let's identify the intercepts. And remember, we have 2 different types of intercepts. Let's first find the x-intercepts. So where it's intersecting or crossing the x-axis or touching. So first one is here at 0, 0. We have another x-intercept here at pi over 2 comma 0. Then we have a third x-intercept at pi comma 0. And a fourth x-intercept at 3 pi over 2 comma 0. And a fifth x-intercept at 2 pi comma 0. So those are the x-intercepts, but we also have y-intercepts. And that is also here. It's a point that we've already identified as an x-intercept. That's not always the case. Sometimes they're different. Our y-intercept is 0, 0, the origin. Okay, a few more questions. How often does the line y equals negative 1 intersect the graph? Let's draw the line y equals negative 1. And then let's count how many times it intersects the graph. 1, 2, 3, 4. So it intersects the graph in 4 places. For what value of x does f of x equal negative 2? So we want to know the x value when the y value equals negative 2. So we need, let's draw a line at y equals negative 2. And it hits the graph in 2 points, 3 pi over 4, comma negative 2, and 7 pi over 4, comma negative 2. So our 2x values are 3 pi over 4 and 7 pi over 4. Those are the 2x values where we have a y value of negative 2. One last question. Apparently some of that got erased. For what values of x is f of x greater than 0? So this is asking for what x values is this graph above the x-axis? Are the y values positive? And part of that is where I've shaded it here. I want to know the x values of this shaded region, and I want to know the x values of this shaded region. So I go from 0 to pi over 2, and I am not including, like I have curved parentheses in this interval, because at 0 and at pi over 2, f of x equals 0, and we only want to know where it's greater than 0. So that I'm not including the boundaries. And then the second interval is from pi to 3 pi over 2.